Human beings have always been fascinated by the objects that fill the sky. The stars, the planets. But the two most dominant features in our sky have always been the moon and the sun. Our sense of time has been molded by the apparent passage of the sun across the sky and by the cycles of the moon. Ancient monuments, such as Stonehenge, reveal the importance our ancestors attached to the movements of the sun and the moon. We have sought throughout history to understand the way the sun, moon, and planets relate to each other in space, to explain their motion and predict the onset of eclipses. Eclipses of the sun and moon have always been a source of wonder and concern. Abrupt disturbances in the regularity of the heavens. To many ancient people, they represented demons trying to devour the sun. Scientists throughout the ages have studied eclipses in order to learn more about the nature of the sun, the moon, and the earth. The earth is in perpetual orbit around the sun. The moon, in turn, orbits around the earth. Both are illuminated by the sun. An eclipse occurs when the shadow of one of these bodies falls across the other. This is a solar eclipse. Whether you witness a total or only a partial eclipse depends on where you are in relation to the shadows being cast on the earth. There are two distinct regions of shadow during an eclipse. The inner core of dense shadow, called the umbra, and the surrounding region of partial shadow, called the penumbra. When a solar eclipse is seen from the region covered by the penumbra, only a part of the sun's surface is hidden by the moon. This is a partial eclipse of the sun. But when seen from the area covered by the dense shadow of the umbra, the sun is completely blocked out by the moon. This is a total eclipse of the sun. Even though the sun is 400 times larger than the moon, during an eclipse they appear almost the same size because the sun is also 400 times further away. A lunar eclipse occurs when the moon, as it orbits around the earth, falls into the earth's shadow. Here we see the first stages of a lunar eclipse. In the 2 hours it will take the moon to travel through the shadow area, it will have traveled a distance of about 5,000 miles. As the eclipse ends, notice the rounded shadow the Earth casts on the moon. Unlike the monthly phases of the moon, an eclipse always casts the same rounded shadow. This helped to convince the ancient Greeks that the Earth was spherical. The moon orbits the Earth approximately once every month. Yet lunar eclipses do not occur on regular monthly intervals. Imagine a straight line passing through the centers of both the Earth and the Sun. If the Moon passed directly through this line in its journey around the Earth, we would see monthly eclipses of both the Sun and the Moon. But the orbit of the Moon places it above or below the line on most of its revolutions. Unless the three bodies are all in alignment, the shadows of both the Earth and the Moon fall off into space, and no eclipse occurs. Even when the Moon's shadow reaches the Earth during a solar eclipse, it covers an area no more than 160 miles wide. Sweeping across the planet at more than 1,500 miles an hour, it passes ground observers in less than 7 minutes. On the ground, beneath that shadow, the clouds darken, and the landscape is cast into twilight, and then darkness. And now the eclipse reaches totality. Just before totality, we see only a thin crescent of the Sun's chromosphere, the gaseous atmosphere that envelops the Sun. The spots at the Sun's opposite edge are called prominences. Prominences are gigantic streamers of luminous gas that loop and arch out as far as 250,000 miles from the Sun, at speeds of up to 250 miles per second. Completely covered by the Moon, revealing the glow of another gaseous layer surrounding the Sun and the chromosphere. This outer layer is called the corona. The gases of the corona are thin, and they reflect and scatter light to produce a halo effect. Although observers here on the Earth can only view the corona during an eclipse, it is always there, extending more than 5 million miles outward from the Sun. The outermost rays of the corona can reach out as far as the Earth, heating the upper atmosphere and influencing our magnetic field. The northern lights are caused by radiation from the corona. As the Moon passes on, the full light of the Sun returns as quickly as it vanished. Long before we understood the true nature of the Sun, we understood its vital importance to all life on Earth. But as we have learned more about the Sun, about the Moon, and the way they interact with the Earth, we have also turned our questioning eyes out towards the stars, to the galaxies beyond our own. The eclipses, so frightening and dramatic to our ancestors, are only local events among infinitesimal specks within this vast universe.